Today we're going to cover section 4.1 and 4.2, so it's over scatter plots and linear regression. Make sure you have the guided notes and you will need a graphing calculator. Okay, so this picture here is an example of a scatter plot. So basically you're going to be given x and y coordinates and plotting those points all over the axis. So a scatter plot is a graph in which the values of two variables are plotted. Okay, so just like any xy coordinate. And then you're going to plot those all over a graph. Okay, so with a scatter plot, there is something called a line of best fit. So a line of best fit, or a best fitting line, is a straight line that best represents the data. So given a graph, since the points are scattered all over the place, you're going to try to draw a line through all of the points so that roughly half the points are above and half the points are below that line. Okay, if the data is too scattered, sometimes a line of best fit is not possible, so there would be no such line. So I've given you three different graphs, A through C. Okay, so if we start with A, if you look here, all of the data points are fairly close together. So all you need to do is draw a line that's roughly through the center of all of those points. So it does not have to be perfect. So a line like that kind of divides the points in half. So that would be considered a best fit line. Okay, same thing with number 2. Draw a line roughly through the center. Okay, number 3, if you look, the points do not look like they form any kind of a linear formation. They're very scattered. So this one, there would be no such best fitting line. Okay, so from a best fit line, we can identify something called the direction of correlation. So to find that, we're going to look at the line of best fit. Okay, after you draw your line of best fit, there's 3 different scenarios. So the first scenario is that the line that you drew has a positive slope. So remember, if it has a positive slope, it's going to look something like this. So if it is a positive slope line, that means that it has a positive correlation. In the second case, if we drew a negative slope best fit line, remember, negative slope looks like this. This means that it has a negative correlation. And then the third case, if we had no line for a best fit, that means that this would have no correlation. Okay, so those 3 scatter plots that we just did, let's identify the direction of correlation. So if we go back and we look at example A, so this was our best fit line for example A. So it's going up and to the right. So example A has a positive slope, which means that it has a positive correlation. Okay, B, if we look at our best fit line, that one has a negative slope, so this one would be a negative correlation. And then C, we said there is no best fit line, so this would be no correlation. Okay, so that part we're always going to do by hand. So that was considered the direction of correlation. Now we can also talk about the strength of the correlation. So strength of correlation, there is a correlation coefficient. And that is R, which you can get in your calculator, and I'll show you how to do in 1 second. So R measures the direction and the strength. Okay, so for instance, if we got R was a negative number, then the direction would tell us that it had a negative correlation. Same thing, if it was a positive number, direction would tell us it had a positive correlation. So there are 3 different types of correlations. The first one is high correlation. Okay, and then if it has high correlation, the points are very close to a straight line. So the points are close to a straight line, or very close, means that it has high correlation. And then R will be close to 1. Or we could say negative 1 if it had negative correlation. So it's going to be close to 1 or negative 1. There's moderate or low correlation. Okay, so the first one, the high correlation, they're very close to a straight line. For moderate or low, they are just semi-close. And the last one, no correlation. These would be not close to straight. So the R values, remember, come from your calculator. If it's a high correlation, an example of an R could be like 0.97. So that number is very close to 1, so those points would probably be pretty close together. If it's moderate or low, probably be something about 0.75. These are just examples, remember. And then if it's no correlation, could be something like 0.01. Okay, the least squares regression line. So we're also going to get this formula from the calculator. So least squares regression line, there's an abbreviation, it's just LSR. So this means the exact same thing. Okay, the least squares regression line is just the formula, or it is the line of best fit. Okay, and it goes through the point x bar, y bar. Okay, so x bar, y bar will come from your calculator. So after you graph your data and you graph x bar, y bar, your line of best fit, or your LSR, is going to go through that line. Okay, it's called the least squares regression line because if you look down here at this example, we have all these points for our scatter plot. So we draw these boxes, or these squares, to touch our best fit line. And the area of these squares is the minimal amount of the area that we could come up with. Alright, so let's look at what the equation, the formula for the equation is. Okay, so the equation, this stands for y hat, is equal to a plus bx. Okay, so a couple different things. The y hat, this is the predicted y value. A is the y-intercept, and then b is the slope. So whenever we do graph these, I don't expect you to graph them perfectly, but I do expect them to go through x bar, y bar, and to be a semi good line. Okay, so there are a couple steps onto your calculator. So you're going to have to be able to go to list like we have been doing, except this time we're going to have two different lists. So step 1, remember you're going to enter values into L1 and L2 because we have a list 1 and a list 2. Remember, this is found under stat. Okay, once we get those entered, then we're going to go back to the stat button. We're going to arrow 1 over to calc. And then we're going to go down and select option 8, which says LINREG, so linear regression, of A plus BX. Okay, once you get that, then we need to put L1 and L2 in the calculator. So to find L1 and L2, for L1 you're going to do second and then the number 1. L2 you're going to do second and then the number 2. So those are the only steps. Third step is just sometimes for some people. So whenever you go to calculate, if r and r squared do not show up, you're going to go to second, 0, scroll down until you find diagnostic on, and then you're going to hit enter twice. After you do that, then you're going to repeat step 2. Okay, this is only if it's necessary, and then once you get to second, 0, it's a big list and it's in alphabetical order, so it's going to take you a little bit to scroll down. Okay, so let's look at our first example. Okay, so we're given 2 different sets of data points. So first, we are going to enter them into list 1 and list 2, and then we're going to find the means, plot them, and then find our least squares line. Okay, so I'm going to call body weight X, and then backpack weight Y. Okay, so this right here tells me an ordered pair. So my first ordered pair should be 120 for my X value and 26 for my Y value. The second column tells you another ordered pair, so this would be 187 and 30. The next ordered pair would be 109 and 26. And then 103 and 24. 131 and 29. 165 and 35. 158, 31, 116, and 28. So I'm going to start by making my scatter plot by plotting those points. So plot 120 26, and do all the remaining ones. Okay, so I have all mine plotted. If you're not finished, go ahead and push pause so that you can plot yours. Okay, if you look, our points are pretty close to a straight line, and it looks like the best fit line is going to have a positive slope. So there should be a positive correlation, and it should be pretty close to 1. So let's go to our calculator. We're going to enter the values into list 1 and list 2. So remember, to get to our list, we're going to go to Stat, Option 1, which should be Edit. So we should have a list 1 and a list 2. If there's something in there, go through and clear both. So under list 1, I'm going to enter all my X values. So 120, 187, all the way to 116. Once I entered my last X value, arrow 1 over so that you're under L2. And then enter your Y values. So 26 all the way to the 28. Okay, so for the first part, we want to find the mean for the body weight and for backpack. So body weight we called X, so that's going to be X bar. Backpack we called Y, so that's our Y bar. So we're going to do this almost like normal. We're going to go to Stat, over to Calc. This time we have 2 variables, though. We have an X and a Y, so scroll down to number 2, which is 2 variable stats. And then go through and calculate. So we should see that our X bar is 136.125. Scroll down and then you should find Y bar. So Y bar is 28.625. Okay, so now let's find the equation for the least squares line. So now I still have all my numbers in list 1 and list 2. So I'm going to go to step 2 of those graphing calculator steps that I gave you. So we're going to go to Stat, over to Calc again. Scroll down to option 8. So it should say linear regression A plus BX. Okay, so make sure you have L1 and L2. If some of you came to the main screen, this is where you're going to have to do second 1, comma, second 2 to get L1 and L2. And then calculate. And then you should get A, B, R squared, and R to come up. Remember, if R squared and R did not come up, I'll go ahead and walk through this step. So we're going to hit second 0. So we should be on catalog. Scroll all the way down until you find diagnostic on. Okay, once you find diagnostic on, hit enter. Hit enter one more time so that it says done. And then we're going to repeat step 2. So Stat, over to Calc, down to option 8, and then calculate. So now R squared and R should be up on everybody's. So we want the equation for the least squares line. So if you go up above, remember it's Y hat equals A plus BX. So the Y and the X are variables. They're always going to stay in our equations. So A should be about 16.26 plus B should be about 0.09 times X. So this will be the equation for our line. Okay, so now let's go and graph our line. So remember, the line has to go through the point x bar, y bar. Okay, so our x bar is 136.125 and y bar is 28.625. So I'm going to plot this like it was any other point. The only thing I'm going to do different is I'm going to label x bar, y bar. So this point right here was my x bar, y bar point. So my line has to go through there. And then remember, the A value is the y-intercept. So our A value is 16.26. So I'm also going to plot that point. So this would be my y-intercept. So now whenever I go to draw my line, I'm going to connect my y-intercept and my x bar, y bar. So that would be my least squares line, or my line of best fit. Okay, so for part C, if a student weighs 146 pounds, we want to know what the weight of the backpack should be. So if you come back up to our chart, we said that body weight or student weight was our X value, backpack weight is our Y value. So we're going to use this equation. We want to know the backpack weight, so that means we're trying to find Y. So we have 16.26 plus 0.09, but instead of X, they're telling us the body weight is 146. So plug in 146 for X. Use your calculator. We should get about 29.4. Okay, and then one last thing, if you go, we'll work more with R and R squared. But if you go and look at R is about 0.8, so it's fairly close to 1, so that's kind of what we expected since our points were close to a straight line. All right, let's do one more example. Okay, so this time we're looking at the age of calves and their weight. So they tell us X is the age and that Y is the weight. Okay, so let's start the same way by plotting all of our points. So our X value is 1, our Y value is 42. That should be our first point. And then 3 and 50. Okay, so plot the 4 remaining points. Okay, so again, our points are pretty close to a straight line. So it should be a pretty high positive correlation. Okay, so let's enter our X values and our Y values. So we're going to go to Stat, Edit. Make sure you clear both of your lists. So under L1, let's enter the X values. So 1, 3, all the way to 36. Arrow over under list 2, do your Y values. Okay, so we want the mean for X and Y. So remember, we're going to go to Stat, over to Calc, scroll down to 2 variable statistics. So this should show us that X bar should be about 15.33. And then if you scroll down, Y bar should be about 102.83. Okay, so I'm going to go ahead and plot that because remember this tells us a point. So 1 point should be 15.33, 102.83. Make sure you label that that's X bar, Y bar. Okay, now we're going to find the actual line. So remember everything's entered in your calculator. So you're going to go to Stat, over to Calc, select option 8, and then Calculate. So y is equal to a, which is 33 point, I'm going to round it to 70, plus b, which is 4.51 x. Okay, so to finish our line, remember this value tells us our y-intercept. So on the y-axis, let's plot the point 33.7. Now we can complete the line by connecting our y-intercept with our x bar, y bar. Okay, for the last thing, a calf is 7 weeks old. We want to know how much the calf should weigh. So remember, y is weight. So using the above equation, that means we're solving for y. X is the age, and it tells us the calf is 7 weeks old. So we're going to plug in 7 for X. So you should get about 65.27. Okay, if you had trouble, if you missed something, go back and watch that part of the video. The notes are posted on my website, so you can go through if you missed a piece and see if that helps at all. You do have a homework assignment, so please show the substitute the guided notes, and she'll give you your assignment. You should be able to finish all of this in class, so once you finish, just work on something quietly until the end of class. And then remember, Friday we have that makeup day, so if you have any questions, if you're going to be here, we can go over it Friday. If not, we can go over it Monday.